Hello guys, this is me. My name is Joseph AGK OG. I'm here with you again. The topic today will be conditional probability. Conditional probability. Conditional. Now, I always tell my class that unfortunately, many things we do in life are conditional. Most things we do in life, or most things we get, are conditional. Even love is conditional. When a man tells you that he loves a girl, look at the girl, or ask him why do you love her. He will tell you because she's beautiful, or because she's nice. So you see the condition is there. The same thing with a man. If a woman say, I love this man, usually it's because he has money, he's rich, or he's handsome. So there's always a condition for everything we do in life. And in statistics, we recognize that and we call it a conditional probability. Now let me show you how to calculate this kind of probability. You can see here, there's a line here. This line means given that. And the number here, the letter here is the condition, the actual condition that we're looking for. So you can see that it has the event that has already occurred. That is a condition. And I'll give you an example again. The condition at the beginning I mentioned love, that is conditional. Okay, the lady loved the man because he is rich. That's the condition. Now let us begin. A conditional probability simply means the probability that an event B, of course you can use B or any other letter, B will occur given that A have already occurred. The condition that the event B will occur given that A has already occurred. For example, the condition that Miss Jane will fall in love with Mr. White given that Mr. White is already rich. So the condition is that he is rich already. That means A have already occurred. How about this? The condition that you get a scholarship, given that already you have good grades. See, the condition is good grades. That's always a condition. So this is the how we write it here. The probability of B, this slash here means given that. So I'm gonna let me write it so you can see what I mean by that. See the slash here. It means this line here, okay, means given that. Means given that. Okay? Given that. That's what it means. Okay? So this means that it's given that this slash line here, or the one we have here, means given that. Now, this is the formula for conditional probability. The probability of A given that B have occurred equals the probability of A and B divided by the probability of B. What you will have here will always be the probability of the condition, which is the condition that's right here. Okay? Like I always say, a statistical formula might look like a monster, but actually when you start using it, you will see that it is not a monster. It actually make your life easy. Okay, let's apply this formula here in solving some problems. Okay? Look at this question here. It says, the test results for marijuana use is presented below. This is a test result from a lab, medical lab, for marijuana use. Usually when you're looking for a job, they send you to drug tests to find out if you're using drug. In most cases, if you're using drug, and it will show in your test results, you may not be hired for that job, you know. So, but this is the result that I have for one particular hospital. The question was this: does the subject use marijuana? Positive results and negative results. If you say yes, that means he uses marijuana, and then no, he doesn't. So, but sometimes even if you use marijuana, even if you don't use it, you might still have a positive result. We call it a false positive in statistics. Anyway, these are the results here. Okay, these are the results, and we have a total. So now with this, the question are as follows. It says choose one subject. Choose one subject at random. Find the following probabilities. Okay. The subject tested positive, given that he or she actually uses marijuana. The subject actually uses marijuana, given that he or she tested positive. These two questions, when I ask it in the class, my student will tell me that they are the same. Even though they might look as if they are the same, but they are not. Because of why? Because of what? Because the conditions are different. Look at here, I said the subject tested positive, given that he or she actually uses marijuana. See, the condition is given is that they use marijuana. But here, the subject tested uses marijuana, given that he tested positive. So the condition here is tested positive is different from the condition here, which is uses marijuana. That's why they are different. Part C says the subject tested negative, given that he or she uses marijuana. So let's answer the first one. Of course, you know, like another example, the first thing you do is to find their totals. I added this to this, give me this. This and this, give me that. This and this, give me that. This and this, give me that. And then, you know, so but of the grand total is right here, 300. Okay? We can now answer the question. So we use P for positive result, M for use marijuana, N for negative result. The first question says that the subject tested positive, given that he or she uses marijuana. Okay? It's right here. The probability of positive, given that M, that means marijuana, equals the probability of M and P, that is marijuana and positive, divided by the probability of marijuana, which is the condition here. So let us get our numbers from the table. Now look at this. Marijuana, yes. Or then positive, yes. See, this is where they intersect here. So it's 119 out of 300. That will be at the top. 119 out of 300 divided by the probability of marijuana use. For marijuana use, marijuana is total is 122. So it's gonna be 122 out of 300. Okay, 122 out of 300. Now you simplify this. So I will show you how to get the answer right here with my calculator. As you can see from here, I will open it, turn it on. Again, here using the use of a parenthesis becomes important. Equals 119 divided by 300. I got 119, okay, divided by 300. Okay, I close this the parenthesis, then divided by the denominator, which is put a division sign here, and another parenthesis. I got 122, okay, divided by 300. Okay, I close my parentheses so that when I press the equal sign, this one here, I press it, I get this result here, which is what I have here. So this means that the probability that the subject tested positive, given that he uses marijuana, is 0.975, or you can call it 97.5% chance. I hope that makes sense. I'm sure it does. Okay. Let us look at the next example, which is there. According to the equation, it says the probability that the subject actually uses marijuana, given that he or she tested positive. Okay? In that case, we use this. The probability that he uses marijuana, given that he or she tested positive, means probability of marijuana and positive. Here the condition is different, which is positive. The probability of positive. Now, let us look at marijuana and positive from the table. So, uses marijuana, yes, and positive result 119. I mean, it's 190. You can see right here. Marijuana, yes, positive. See, they intersect here. 119 out of 300. You will have it here like we had before. But at the end, this one, the condition is different. The probability of positive results. This is positive results right here, okay, which is 143 out of 300. Okay, 143 out of 300. So you point this on the calculator, you get the same results. So you put it the same way I put the other one. Let me put it again so you can see. Equals, okay, 119 over 300. I put my parentheses first. 119 by 300. I close my parentheses. Okay, divided by another parenthesis. 143 by 300. I got, okay, 143 by 300. I close my parentheses. And then I press my enter key right here. Okay. You can see 0.832, which is what I got here. 0.832. Okay. So this means that there's 83.2% chance that the subject uses marijuana, given that he or she tested positive. Okay. Now the last example question in that section is this one here. The subject tested negative, given that he or she uses marijuana. So sometimes the subject might test negative, even though they use marijuana. We call it a false negative, but the probability will be very slim. So you have it here. Negative results are here, right here, but using marijuana is yes. See, they intersect at 3 out of 300. See, so you can have it here. Okay, 3 out of 300 divided by the probability that I forgot to put this in here. Let me put it here. I'm gonna put probability of, okay, put here probability of that uses marijuana. Okay, all right, that gives us this value here, okay, divided by the probability of marijuana, which is as you know already. I'll go back here, which is 122, that he uses marijuana. So that he tested negative, given that he uses marijuana, when you put it in 122 out of 300 and put this in a calculator, just the way I showed you, put them in the calculator, the same method I showed you in the other example, you get the results. There's only 2.5% chance. 0.025 means 2.5% chance that the subject will test negative. given that he uses marijuana. Okay, so that's basically what conditional probability is about. Yeah. Let us solve one example more. See, it says here, the table here shows that the result of a study in which researchers examine a child's IQ and the presence of a specific gene in this child. Find the probability that a child has a high IQ given that the child has the gene. This is the table, okay, and you get your totals on the side, and okay, this is gene present, gene not present, high IQ, normal IQ, total. So all these numbers, you add them. Now we are ready to answer the question, which is to find the probability that the child has a high IQ given that the child has the gene. So let us use this H for the child has high IQ, and we use P for the gene is present, so that the probability that the child has high IQ given that the gene is present is equal to the probability of high IQ and the gene present divided by the probability of the gene present. So first of all, let us find this one, which is the probability of high IQ and gene present. Remember that it is at the intersection of H and P. Okay, I have it here. See, gene is present, that's P. High IQ, see, they intersect here, 33 out of a total of 102. So you put it right here, 33 by 102 divided by the probability that the gene is present. See, gene present right here, total is 72 out of 102. Okay, so when you punch this in the calculator, you get this result. See, the same principle. This is basically what probability, conditional probability is. And remember, everything we do in life is conditional. That's it, and we recognize that in statistics. Here our lecture will end. I'm going to see you in my next lectures. I hope you enjoy my lectures. If you do, please give me a review in YouTube, okay, or Google. And don't forget to to subscribe to my channel so you will receive notices when there's a new lectures that are available. Once again, my name is Joseph AGK OG, and thank you. Bye-bye.